Hello friends, now we have enough information about data types, the size of data types, the range of values that each data type provides, different types of operators, how we can use those operators with different data types, and when to use which operator, right? We have also few information about the different class like a math class and the string class, which are very useful. Okay, now whatever the information till now we have, with that can we do something? Okay, today I would like to talk about this, that is, how do you convert the mathematical expressions or physics formulas into code. That is most important. Why? Because when you come across, or when you are working in games, definitely you will come across with such formulas. Okay, it is most important to how to convert the physics or maths formulas or expressions into codes. Okay, you should not do mistake, because I hope you remember when we are learning about precedence of operator, we have seen what problems might occur if you do not write expressions properly, right? We might lose some information, we might lose some data that is most important for us while working with the game, right? So let's get started. What I'm going to do is I'm going to open the Unity, and we are going to create a new project. Let me write expressions demo. Gonna be 2D project and say create project. Now, how do you convert, or what are the steps that you need to carry when you are going to convert an expression to code? Okay, it's the most important part. You are going to follow 4 steps. First step is to identify variables and constants. Now what you need to do is, first step is to identify whether an expression containing the variables or constants, or which symbol is variable and which symbol is a constant. That is the first step. Okay, now once you identify variables and constants, the next thing is to check what type of data the variable or a constant is going to be. Okay, identify data types, identify data types. Okay, you need to identify what type of value this variable or a constant is going to hold, because based on that only you are going to declare a variable or a constant, right, based on the data type. Okay, after that, once you identify the data type, a variable and a constant, okay, next you are going to convert these formulas into codes. Let's take an example for this. The first example is, let's check this one. C is equal to A plus B. Okay, let me write here, let me create one C# script. Right click, create a folder, scripts, and let me create a C# script, expression demo, and I will attach the expression demo. Now we have expression demo class available. Okay, we will see step by step what can we do and how do we convert those expressions to code, because when we will be working in games, definitely these are the different types of expressions that you will find. Okay, this is an example for projectile motion. These two are example for circular motion, or creating the sine waves or cos waves, right, or elliptical motion if you want. And this is Pythagoras theorem, which is very useful to find out the distance between two objects. Okay, these are the different formulas. Okay, definitely when you are working in games, you will be coming across with many physics formulas and many math formulas, which are really handy for us to make games. Okay, and knowing how to convert those formulas to code is also the most important thing of gaming. Okay, so let's start with C is equal to A plus B. Now if you are writing C is equal to A plus B, okay, we very clearly know that C, let us take, is equal to C is equal to A plus B. Okay, now we very clearly know that these are gonna be variables, right? Okay, C is equal to A plus B. A is going to be a variable, B is going to be a variable, and C is going to be a variable. And we need to decide whether we are working with integer types or floating types. Okay, maximum time we will be working with floats, because floats will give us the accurate results, almost accurate. Okay, accurate results, and they are a little bit faster too than double and all. So I can create variable called as float a comma b comma c, and initialize them to, let us take 0 and equal to 0 and equal to 0. Then I can just write C is equal to A plus B. This is a direct expression actually. We have just converted this to code. Let us check it out whether we converted properly or not. Okay. Let us have, we have A equal to 10, B is equal to 10, and C is equal to A plus B. Then we can just say debug dot log C, bracket close. Okay, do you want to convert the line endings? Okay, let us save and check out now whether we get the result as 20 or not. Okay, let's come back. Okay, we don't have any error, and we got the result 20. That's correct. So this is how you convert. So what we have done, first we have checked whether they are variables. Okay, and we created the variables using the required data type that I wanted float. So let us take 10.5f I have, and I want to add with 10.6f. I have stored those variable values now here, and I converted the expression, and I will be getting the result. Okay, let us save, come over here and clear this and run the code. You can see that we got 21.1. that is the result of this operation. Okay, now this is how you are going to convert a normal expression, okay, to code. Okay, let us take the second example. We have area of a circle is equal to pi r square. That's a formula, right? And area of a circle is going to change, right? Because if you give different radius, different area of a circle you will get. And r is the radius, which is going to change, right? You will be giving different radius. But pi is a constant, right? Because It is a mathematical value 3.142 normally we use, right, or 143 we use. That is a constant. Now here you know this is variable, this is a variable, this is a constant, this is a variable, this is a variable. Now you need to know what type of data type you are going to prefer. Of course I am going to use float because I want the result in floating point. Okay. So let us start. Okay, I create a float variable which is going to be known as area of circle, and another one is r, which is going to be radius. Now area of circle will be 0 in the beginning. Okay, so 0.0 f I can say. Radius is going to be, let us take 3.0 f. I am giving a small radius. And now I want a constant float variable called as pi, and which is going to be equal to 3.143 f, let us take, or 1.142 f. Okay, whatever I want. Now this one I have made constant. Can you see how do we declare a constant? Okay, now we can write a formula. Area of a circle is equal to pi into, now we need r square. How do we write r square? R into r. If I write, this is going to be r square. Now remember, anyhow the multiplication is there, but we can do this operation, right? We can put this in a bracket because this part is going to be evaluated first, r square, then it will be multiplied by pi. That will be good. Okay. Now let us debug .log. Okay. Log area of circle, and let us see. Okay, if everything is perfect, we should get the result properly. Let's come back. We don't have any error, and let's run and check out. We got the result 28.278. That is how you are going to convert the formula area of a circle is equal to pi r square. Okay, let us see the next expression. The next expression that we have is circumference of a circle is formula 2 pi r. Now this is an important. When I want to find out the circumference of a circle, you can see that pi variable I have constant I have already created, and r is also created. Only I need to create is one more variable called as circumference of circle. Okay, let us create that variable also. Okay, let me create a float called circumference of circle, which is equal to 0.0 f. I initialize in the beginning. Now I need to write circumference of a circle is equal to 2 into pi into r. That's it. Now we have the r value here 3, so we can find out the circumference also. I can copy this, paste over here. Only thing I need to do is I need to copy and paste over here for circumference. Now let us save and check out whether we get the result or not. Okay, I clear this and run the code. You can see that the result is 18.852. Okay, so we have written we have converted this formula also, that is 2 pi r. Okay, now what else can we do with this? We can use some other ways to do same operation. Now we already know that mathf has a constant called pi. I can use that one instead of creating this variable, right? I can directly use mathf.pi instead of writing this pi in this place, right? Let us do that. I'm going to delete this constant, okay, and directly here I will write mathf dot pi, Let me delete these expressions, and here I will write mathf dot py. Let us save and check out. And run and check. You can see that we got more precision values than previous, and the results are same. Okay, results are almost same. You can see 28 and 18. Right. You can use math class. That is good. And also to write r square, r into r, what we can do is we can use again mathf dot a function called as power. And the power function takes two values, r comma 2. Now this is r square, right? R raised to the power of 2. Now you can see that we are using the built-in functionalities which are very useful, right? Now let us see whether we get the result again properly or not. Okay, you can see that we got the result. Now these are the different ways in which you can convert these two expressions. You can use the mathematical math functions which are already available. Okay, this is how you are going to work with. Okay, I hope you understood how do we convert the expression. Let us take the next expression, a plus b divided by a minus b. How do you do that? Okay, now again first step is to identify the variables. There are only two variables we have, a and b, right? And the data type I prefer is float. Okay, float a comma b. Now let's take a is equal to 10 and b is equal to 10. How do we write that expression? Okay, now let me write debug dot log. Now if you see this expression, now let us take, I will write something like this. Okay, if I am writing in a code, I say a plus b divided by a minus b. This is not a correct one. This is not the correct way. Why? Because we already know that this b divided by a is going to evaluate first. That is having a highest precedence in this formula. Correct or not? So we need to control this precedence. How do we do that? We will be using brackets properly. We have to evaluate the numerator first. We have to evaluate the denominator first. Right? Next, then we have to divide the result one between another. So if I have to write this expression, let's do that code over here. We will be putting a bracket, a plus b bracket close divided by a minus b. Okay, this is how you are going to write the code. Okay, so the result will be 10 plus 10 is 20 and 10 minus 10 will be 0. Oh, can you see that? Let us see. Okay, let's come back and run the code. Let's see what happens now. Okay, let us run and check. Can you see that? We got infinity. That is the float, right? Division by 0. This is, if you have an integer, then you would have got the problem, the error message. But we know that the float has the infinity value, right? Now this is also a very, very important point where you don't know that what will be the denominator, right? Here the denominator went to 0. When you are working in a game, please, you have to first check that a minus b should not be equal to 0. Then this evaluation should work. or execute, like that you need to write. We'll come to know how do we write such expressions later. Okay, but at least now we know how to convert this formula into the code. Let's go to this one. Now how do we write a plus b whole square? One way is you can use the formula called a square plus b square plus 2ab, right? This is the one which is you can. So how do you write a square plus b square plus 2ab? Now already we have variables created, I will use them only. So first we have to write a square. A square means I have to write a into a, that has to be evaluated first. So I will put in a bracket, this is gonna be a square, then plus, then I have to put in a bracket b star b, that is going to be b square, a square plus b square plus, in bracket I put 2 into a into b. This is how you are going to convert a square plus b square plus 2ab. Or you can use the mathematical functions. Instead of writing like this a into a, I can use mathf dot power of a comma 2, that is same as a square, right? Now same mathf I can use over here, only I need to change a to b. This is gonna be b square, a square plus b square plus 2ab. Now I hope you are understanding how the mathematical functions are handy, right, when you are writing expressions. Let us save, come back to the Unity and clear this and run the code. You can see that we got the result as 400. I want you people to manually evaluate whether we are getting the proper result or not. If you are not getting proper result in the Unity here, that means you are having the problem with converting from a formula to code. Maybe you will be having some bracket parenthesis you have placed in wrong place. Okay, that you need to check out. Let's go to the next one. Next we have a formula for projectile motion. Okay, projectile motion means a falling ball, right? When you throw a ball, it will fall in a projectile motion. For that we have this formula. Now let us first identify the variables. We need this y naught is the initial velocity, yf is the final velocity. These are gonna be changing, they are variables. This is the initial velocity which is gonna be changing, because in the beginning you will be setting some initial velocity, or you can put you can give a constant only, because initial velocity anyhow we will be fixing somewhere. Even y naught is also an initial velocity, which initial position, which also constant you can create, right? Then g is the gravity, which is a constant, whereas time is a variable. Okay, let us take, we will fix the y naught, okay, y position to the 0. Okay, that is a constant for us. Initial velocity, let us take 20 we give. Okay, like that, that is a constant. We are not going to change. If you want to change, then we have to create the variables. Now let us convert this expression to code. Okay, let me put the side by side so that it is easy for us to write. Now how do we do that? How do we write? Okay, now first thing, I need few variables. All are going to be float. First one is initial y position. I say iy. Then iy initial position is going to be 0.0f. That is the y position. Initial y position of the object is 0. Okay. Then I need initial velocity. So I use iu, that indicates the initial velocity. And iu is going to be, let us take 40 meters per second, 40.0f. Okay, that is initial y velocity. Okay, then what we need? We need a variable called as final velocity. I chase fy, which is going to be 0.0f, okay, which is going to change based on the formula value. Then I'll be creating the time. So I'll create t variable, which is going to be in the beginning 0.0f, which will change later. Okay, as time changes, the formula also need to change. Okay, now we need g. G is a gravity. Gravity is a constant. So we will create a constant float gravity. Let us take it is 9.8, and that is to it is minus 9.8 f, because gravity will be acting on top, so it's a reverse, right? It's a reverse of y. So these are the variables that we need for the final expression. Now let us write the formula. So final y position should be equal to initial velocity multiplied by time, that is the current time. Okay, at present it is 0. We can change because it's a variable. We put 2, 3, 4, 5, 6. The time will be changing, 1 millisecond, 2 millisecond, 3 millisecond, like that. Okay, now I put this part in a bracket because I know that this has to be evaluated individually, this part, minus half of gt square. Instead of writing half, I can write 0.5, right? That is actually half, multiplied by, okay, now I have to put this part should be evaluated separately. Half of g times t times t, that is half gt square, plus initial y position. This is how you will be having the formula. Now as time is 0, you can see if you multiply this 0 times with this 0, 0 minus this whole thing will be 0, 0 minus 0. So initial y position, whatever you have given, that will be the final y position, right? Initial y position you have given 0. Now if you get the result of fy, definitely the object will be in the same place where it was, because you are not changing the time only. Okay, if you do not change, even though if you give a velocity, nothing will happen, right? So debug dot log, I just pass fy, and let us see the output, what we get. Okay, the output we get is, we have an error called double to float. That means we have written somewhere a decimal without f. Okay, this is a place. Okay, 0.5 I have written. Let me write here f. Now everything will be a float. Let me come back and run the code. We should get here 0, because that is what we have to get. Okay, now let us change the time. Now time is, let us take 1 millisecond, okay, or 1 second let us take. After 1 second, what will be the y position? Okay, we have given an initial velocity also. Okay, now let us see what we get. Okay, if I run the code, you'll see that you will get 44.9. That is the next y position if you have given a velocity of 40, initial velocity. Okay, this is how you are going to convert any expression, okay, to the code. That you should remember. Okay, even you can make it this t square. Instead of writing t square, you can use the mathf again. Mathf dot power t comma 2. That is saying same as t square. Okay, if you run this, you should get a same value, which is 44.9. If I run the code, you can see that the result is 44.9. Okay, that is how you convert a formula to code, which is very, very important, guys. Okay, you should know where I have to put the parentheses. That is also most important. Okay, That is projectile motion. Next, how do you convert this formula? Okay, that is, again you need to identify the variables. Only one variable I have x, you can see, so I can write float x, and let us give at least 1.0 f is the value. It has no value, but initially you can give 0 also, no problem. Okay, now how do you write this formula? Now when you are writing this formula, how do we write? X divided by x divided by 3 minus 1. This is wrong. What we know is numerator has to be evaluated individually. The denominator has to be evaluated individually. Out of this, x divided by 3 has to be evaluated individually. Then minus 1 we will be doing. Now how do we write that in a code? Is x is equal to x divided by bracket, one more bracket, x divided by 3 minus 1. Okay, this is how you are going to convert this code, this formula to the code. Okay, let us debug dot log value of x. Okay, so what we get? 1 divided by 3 minus 1. Okay, let us see the result. What we get? We got minus 1.5 something. Okay, now let's take the next one. Okay, the next formula is c is equal to square root of a square plus b square. How do we do that? Okay, now here we have three variables, so I just create three variables, float a, comma b, comma c, which is a Pythagoras theorem, right? It is about right angle triangle, right? If base is a, side is b, then this will be c. You want to find out this length, then you will be using c is equal to square root of a square plus b square, which is very useful. We will see how it will be useful in games. Okay, let us take a is equal to 3 and b is equal to 2. Let me write 2.0 f and a is equal to 3.0 f, and let us see what will be the value of c. Okay, now how do we write? C is equal to math f dot sqrt is a function we have to use, square root of, I have to write a square plus b square. So if I have to do a square plus b square, I can use a into a plus b into b, like this. This is the formula. Okay, and we converted it to the code. Okay, now we can see debug dot log c. Okay, let us save it, run and check. And if I run the code, you will see the result as 3.60551 something. Okay, let me check this one to 5, or let me take this one to 3 and save and check what result I get. Clear this and run the code. So we are getting the result 4.24 something. Right. Now instead of writing like this, a square, b square, we can use the math function if you want. Let us take here, I will write math f dot power of a comma 2, that indicates a square. Then here math f dot power of b comma 2, that indicates b square. So we have square root of a square plus b square. Okay, let us save and come back, clear this and run the code. And you can see that the result is 4.24264. That's correct. Okay, I want you to check the manually you need to work. Okay, mathematics part. Now let us take the next formula. Now these are used for circular motion or sine motion or a cos motion, harmonic motion, that is what we say, right? Or elliptical motions we will be using. Now how do we write this formula? Okay, f of x is equal to cos theta into frequency times amplitude times initial position. Okay, that's the final position. Initial position is a variable, amplitude is a variable, frequency is a variable. Even sometimes you will write theta. Theta is, you have to write this one as a variable because this symbol is not available for us. Okay, let us write. Okay, you can see that I'll write the expression over here first. I create float variables, initial x position, final x position I need, then I need a theta variable, then I need a frequency variable, then I need amplitude variable. Okay, these are the variables we need. And when I say final x position should be equal to math f dot cos of theta. Okay, theta. And remember that this function cos is going to take the radians. So here if you write theta is equal to 90.0 f, 90 you are telling in degrees. So you have to convert this degree into radians before you give it to cos function. So what we do means we will multiply this with math f dot or how do you convert degree to a radian? Okay, degree to a radian, that is 180 degree is equal to pi radians. Okay, so pi is the most important for us now. Okay, degree and pi. Now okay, let us take 90 degrees there. You want to convert it to radian, you have to multiply it by radians divided by degree, 180. So 0 0 get cancels, 9 1 ja, 9 2 ja. The result will be pi by 2. Okay, you have to multiply your degree with this value, pi by 180. So we can write it as multiply by math f dot pi divided by 180, which will give you the result. Then you can multiply this with the frequency, bracket close, multiplied by amplitude plus the initial x position. Can you see that? This is how you are going to write a formula for this. Theta into frequency. Okay, this part you can put in a bracket because that will be much more better, right? So this will give you the radians multiplied by frequency multiplied by amplitude, initial velocity, initial position. Okay, then you can debug debug dot log the value of f of x. Okay, so theta is 90 degree. Let us take frequency is equal to 2.0 f, twice the speed, and the amplitude is equal to 2.0 f, and initial position is going to be, let us take 100.0 f, that is the initial x position. Then f of x, final x position will be 0.0 f. Okay, now what result we get after doing this evaluation? Okay, let us see. If I run the code, you see the result is 98. That will be the next final x position after evaluating this. Okay. This is how you are going to convert the mathematical expressions to codes. I want you people to go through some more mathematical expressions and get used to how converting from formulas to codes, because this is most important when we are working with games, because we will be working with these all like different types of expressions. Okay, so that is all about how do you convert, what are the steps you need to carry on while converting normal formulas to codes. So thank you very much guys, see you in the next tutorial.